Good morning, girls. In the last class, we have discussed about various states of the thread, like how to create a thread. The first and foremost thing is how to create a thread. What is a thread? Okay, and what is the difference between thread and process? And as well, creation of thread using in two ways, using a thread class and using runnable interface. In what kind of situations we use uh, we create thread using thread class, and where we go for runnable interface. All these are the things that we have discussed in the last class. uh, we are going to discuss today the most important topic of life cycle of a thread. This can be your an essay answer question, or any two states can be asked as a 4 marks question or short answer question. So this is the most important topic of this whole multi-threading concept. So life cycle of a thread. So how a human being has a life cycle, like uh, from a toddler, next to a kid, next to a teenager, next middle age, next old age, like that. Here also, the thread, those are the stages which we can't reverse back. Okay, and just I have said you to how a human life has different stages. In the same manner, a thread which is born will also have different states or different stages, which are very important, which play a very important role in the running of that thread. So, during the lifetime of a thread, there are many states it can enter. So, the what is lifetime? Lifetime is nothing but the time from or the second, when the thread is born to the second when the thread is dead. I mean, it's killed or whatever, automatically it has reached its end or whatever it might be. So, lifetime constitutes the uh, period in between these two uh, points. So during the lifetime of a thread, there are many states it can enter. The thread can move from one state to another state. So what are the states that is going to enter, move back and forth from these states? What does it do in these states? That is what we will see in this life cycle of a thread. So these are the 5 states in the thread which the thread can have. One is newborn state. Next is runnable state. Third one is running state. Fourth, blocked state. And fifth, dead state. So these are the 5 states which the thread will be in at any point of time if it is alive. If it is alive, except this dead state, these are the 4 states in which it can be when it is alive. So a thread is always one of these 5 states. It can move from one state to another via a variety of ways. So this is the diagram. If you see this diagram, it shows how a thread will traverse or move from one state to the other state and come back. Uh, Everything is shown in this pictorial representation. See, once the thread is in the new state, it will start. Okay, when it gets started by using start method, it can be into running state and runnable state. So the thread will move from running state to from runnable state to running state, running state to runnable state. So this it can move. It can be in any of these um, states. So mainly after the thread starts, it will be in runnable state, and once the processor allocates time, it will move to the running state. And from these two states, so the I mean, when the thread is working, it will be in this state, running state. So from these two states, it can move to the blocked state by using these methods. It can be moved by us to this blocked state by using any of these 3 methods: suspend, sleep, and wait. So once it moves to blocked state, it can be brought back or it can get back to runnable state by using these two methods, resume and notify. Okay, or it can move from this blocked state to directly the dead state. Or here also you can see from newborn state it can directly move on to the dead state. So for this we are using the method stop, stop, stop. So from any of these states, I mean from running to runnable state also it can move on to the dead state. So these are the three states from which the thread can be moved on to the dead state. Newborn state, running or runnable state, or blocked state. From any of these three states, it can be moved to the dead state. So once it is dead, it's called killed thread. And when it is in newborn state, it is a new thread. When it is in the runnable or running state, it is called active thread. When it is in the blocked state, it is called idle thread. Idle in the sense it is doing nothing. It is still. It has no work to do. Sitting idle. So it is not in the runnable state. So these are the states have. The thread moves on from one state to the other state. So what is the newborn state? See, when a thread object is created, the thread is born and is said to be in newborn state. So when uh, how a kid is born, he is called newborn kid. In the same way, when the thread is created, it is said to be in the newborn state. So the thread is not yet running. So it is not running. It has to be scheduled for running. What does it mean by scheduling? That means the processor has to give it the time, give it the time to execute the body which is written in that thread. So then it's said to be into the running state. So in order to move to the running state, first it has to enter the runnable state. So at this state, only one of the following things can happen with it, can be done with it. What they are. Schedule it for running using start method. So once the thread is born, it is in newborn state. So by using the start method, so how you will so how will you move the thread from newborn state to the runnable state by using the start method. Or if you don't want to start the method, you can stop it or you can kill it by using the stop method. So either you can start it or you can stop it. If you start it, it moves to the runnable state. If you stop it, it moves to the dead state. Next. Say, if scheduled, it moves to the runnable state. So the newborn thread can move to the runnable state or dead state if you schedule it. So how you schedule it? By using this start method or stop method. An attempt to use any other method at this stage will throw an exception. So the only two methods that can be applied on this um, thread at this particular stage, newborn stage, are start method and stop method. If you try to use any other methods like sleep, wait, all these, if you try to use these methods, then they will be showing you an exception or an exception will arise. Next, so what is a runnable state? See, so what does the runnable state signify? The runnable state means that the thread is ready for execution and is waiting for the availability of the processor. So the processor is busy with some other work and the thread has got created and it's waiting and you have moved the newborn thread from new, newborn state to runnable state using start method. So when the thread is said to be in runnable state, when if it is ready for execution, it will start execution if the processor is giving it time to execute. So thread is ready for execution and is waiting for the availability of the processor. So The processor is the main thing which is responsible for the execution of this threads, right? So the processor should be available for the thread to run. So if our thread is waiting for the processor, then it is said to be in runnable state. See, the thread has joined the queue of threads that are waiting for execution. So it is not the only thread. Already there are some other threads created by some other processes or by the same process or by the same program. So this new thread is will join that queue, like how we wait for tickets at a movie counter, or how we wait for milk packets at a milk booth. In the same manner, for the processor time, all these threads are waiting for the execution. So if all threads have equal priority, they are given time slots for execution. Excuse me, in round robin fashion. So that is first come first serve manner. Same, yeah, how the people standing in a queue will get the chance to get the ticket. So here also, how the threads are given the priority. If all the threads are having the same priority, then automatically they will be served in first come first serve manner, which is called the round robin method. Okay, so one by one, as in when the processor gives them time, they will be executed. So the thread that relinquishes control joins the queue at the end and again waits for its return. So one, say for example, one thread is already executing and other threads are waiting here. So once this thread uh, finishes its execution, it relinquishes. Relinquishes, it leaves the processor. I mean, it the control of the processor will be left when it leaves. The control is passed on to the other thread which is in the queue, next thread. So it will take after processor time, and this old thread till now which has got executed will be joining the queue at the end. It can't come in the middle, same as a line or queue, uh, like we stand in our day-to-day life. So it has to join at the end of the queue and again wait for its turn. Next, this process of assigning time to threads is known as time slicing. I mean, dividing the time between the existing threads. Say, for example, if I have 10 threads and I have if I have 10 threads and I have 20 minutes of time, so how will I divide the time between these 10 threads? I will be if all these threads are of equal priority or same priority. So how the time is divided, like each thread is given 2 minutes of time. So once the 2 minutes get completed, the processor will leave this thread and it will move on to the next thread. The thread which is left here will move to the queue and join at the end of the queue. So this division of time between the threads for the execution is called time slicing. This can be asked as just short answer question. What is time slicing? The division of time between the threads for execution or for getting the processor is called time slicing. See, if a thread has to relinquish control to another thread to equal priority, it before its turn comes, it can be done using yield method. See, if a thread wants to relinquish control to another thread to equal priority before its turn comes, see, this is the running thread. I mean, the processor is excuse me, the processor is executing this thread. Now it wants to allocate or give the processor to this thread. Actually, these two threads are in line, all these threads are in queue. So if the processor leaves this thread, it has to come to this thread. But if this thread wants to, I mean, give the control to this thread, all these threads are of equal priorities. See, if the priority is of this thread is more, automatically the person has to come to this thread. But all these threads are of equal priority, and now this thread wants to give the control to this thread. So how it can shift the control is by using this yield method. Yield method is used to change or relinquish or send the processor from the running thread to the thread which the running thread wants to give, provided all the threads are of equal priority. So actually, if its turn has to come, these two threads have to be given to the processor and they have to get executed. They have to finish, and then the processor comes to this thread. But to surpass these two threads, and the control has to move to this third thread, in such case you have to use a yield method. Next, running state. See, what is running state? Running means that the processor is given time to the thread for its execution. So actually this is waiting for the when the thread is waiting for the uh, processor time, it is said to be in runnable state. The next stage of newborn state. So when the thread I mean take is given the time by the processor, or the processor takes control of the thread for execution, then it is said to be in running state. The thread runs until it relinquishes control on its own, or it is preempted by a higher priority thread. Relinquishes means it leaves. It leaves on its own. Once the time given to it is over, or the work which it wants to do has been finished. In both the cases, it relinquishes the control, or it is preempted. Preempted in the sense, a thread which is having more priority than my priority. Like if I have a priority of 5, and the next thread in the queue or the upcoming thread is set to priority of 7 or 8, then automatically the controller will leave this thread or my thread which is running at present, and move on to the thread with this higher priority. So the thread will be running in this and will be in this running state until it leaves the control on its own. How it will leave the control on its own? Either it has to finish the time allocated to it, like 2 seconds or 3 seconds or 4 seconds, whatever time it's divided to it, given to it. And second one, the work which has to be done by the thread is completed. It might be a very short, a small amount of work, it may get completed. So in both the cases, it will relinquish the control, or it is preempted by a higher higher priority thread. Some other thread which with higher priority is taking the control from the it is requesting for the control of the process. So a running thread may relinquish its control in one of the following situations. So how in when the running thread will relinquish, leave its control, or will leave, leave its control. The first one is it has been suspended using suspend method. So it is being suspended by using suspend method. So why do we suspend the method? There might be many reasons to suspend the method, like the resources which are required for this running method are being used by some other threads, or any reason. Because of any reason, if it has to move from running state, it has to be the control has to be taken from this running thread, then we use the suspend method. So once the suspend method is called, then the running thread will move into suspended state. So a suspended thread can be revived by using the resume method. So always the thread can't be in the suspended state. So after some amount of time, it has to move back to the runnable state. So how it will be, it will get back from suspended state to the runnable state by using this resume method. So this is what is how the thread from running state will move to the suspended state, and it will come back to the runnable state. So once it is in runnable state, it is ready or waiting for the processor to allocate time to it. So this approach is useful when one wants to suspend a thread for some time due to certain reason but do not want to kill it. So I don't want to kill the thread. I mean, I don't want to end the thread. I just want to make it sit for some time or make idle for some time. So then I will use the suspend method to shift the thread from running state to the suspended state, and you can just get back the thread from suspended to runnable state by using the resume method. Next, it can move uh, to the suspended state by using another method also, that is the sleep method. So it can be made to sleep. So one can put a thread to sleep for a specified time period using the method sleep. Sleep, it's carrying the, what you said, parameter like time. So that time is nothing but the amount of time for which this thread has to sleep. So this time is generally given in milliseconds. It has to be counted in milliseconds. This means that the thread is out of the queue during this time period. The thread re-enters the runnable state as soon as the time period is elapsed. I mean, as soon as the time is finished. See, for example, 5 milliseconds or 10 milliseconds, automatically the thread will move from suspended state to the runnable state. I mean, it will join the queue. Now it is not in the queue. When it is in the suspended state, it is not in the queue. Only the threads which are waiting for the processor control will be in queue, will be in the queue, runnable state. Uh, so you can send the thread which is in running state to suspended state using two methods. One is suspend. If you use suspend method, you have to use resume method to get it back to the runnable state. If you use sleep method, automatically after the time elapses, if the time gets finished, like an alarm, if you set at a particular time, it reaches that time, it will start giving us the alarm. It will start making sound. So in the same manner here, once the time is finished, the time for which you have set it to sleep, it's finished, it comes back to the runnable state after the particular time. Next, next is, it has been told to wait until some event occurs. So again, the other way which you can put the you can shift the running thread to when put it idle. It is not in suspended mode, it is in waiting mode. So you will use this method called wait method. So what is the differences here? You are specifying the time for which it has to sleep, or you are asking it to wait, and you will notify it to resume when you feel it is required. But here you will ask the thread, or the thread will be moving to the waiting state by using this wait method, and it will only return back when the a particular event occurs. So when some event occurs, that will trigger, or that will cause this thread which is in the waiting state to get back to the runnable state. So for this wait, you have to use this notify method. So the thread can be scheduled to run again using the notify method. So you are asking this thread to wait until some event occurs or something to happen. Till then you ask it to wait. So it has to wait for that event to occur. So when that event happens, you will notify it to come back again to this runnable state. So these are the three ways in which you can relinquish the thread which is in running state to suspended or waiting state. Blocked state. So what is blocked state? See, a thread is said to be in blocked state when it is prevented from entering into the runnable state and subsequently the running state. So when the thread is not allowed to come into runnable state. So if it is not coming into runnable state, automatically it will not come to running state, because every thread has to enter into runnable state. I mean, it has to. What is runnable state? Nothing but waiting for the processor. So here there is a queue of threads which are waiting for the processor time. So always the new threads will be joining the queue at the end. So when a thread is unable to enter into this runnable state, so it will not enter into the running state. So if a thread is prevented, then it is said to be in blocked state. So when this happens when thread is suspended, sleeping, or waiting in order to satisfy certain requirements. So when the thread is in any of these states, like it is suspended, or it is made to sleep, or it is waiting for an event to occur, if it is in any of these three states, then it is said to be in blocked state. So a blocked thread is considered not runnable but not dead and therefore fully qualified to run again. So a blocked thread is not a dead thread. So it can resume back. It is just sitting idle for some time because of these reasons, like you have set a timer to sleep, or you are waiting for an event to occur, or you have suspended it for some reason. Then the thread is said to be in blocked thread. So it can resume back, it can get back, or it can join the thread, queue, runnable thread queue, the threads which are in the queue for waiting for the processor. So then that is called a blocked state. So what is dead state? So every thread has a life cycle. So a running thread ends its life and it has completed executing its run method. It is natural death. So once it completes the execution of the thread, the whole thread gets executed. There are no other what you say uh, lines of code to execute. Thread is completed as a whole, then it will automatically move to the dead state. It's called natural death because its work is over. So automatically it can end it. It gets ended. So that is what is natural death. But if one tries to kill the thread by sending the stop message to it or at any state, it is called premature death. So it is called premature death. So if it dies on its own after the completion of its execution, complete execution, if it has something to execute again and again, it has to mm, move to the runnable state. It has to go and join the queue. But the whole thread execution is completed. No lines of code is there for execution next. Then it will die automatically. But if I want to stop the thread from getting executed because of some reasons, any reason, then I have to send a stop message which will kill the thread, and this is called premature death of the thread. So a thread can be killed as soon as it is born or while it is running, or even when it is in non-runnable, that is blocked condition. That is what we have seen in this diagram. See, a thread can be killed as soon as it is born or when it is in this state, active state, like when it is in runnable state or running state, or when it is in blocked state. So from any of these three stages, it can be moved to that state by using the stop method, but this is called premature death. So this is all about your life cycle of thread. So in the next class, we'll be discussing about thread priority, thread synchronization, and various methods of the thread class. Okay. If you have any doubts, ping me in the group.